batteries. So in lithium, we have two kind of batteries basically. One technology is known as NCM battery, which is a technology which works on 3.7 volt. And we have another technology which is known as lithium iron phosphate, which is a technology which works on 3.2 volt. So in lithium, we have two types of cells basically. One is 3.2 volt and one is 3.7 volt. So depending on the use and depending on the energy requirement and energy density, like suppose you take a case of a electric bike, motorcycle. So it is a very compact. So the energy density is very high there. The battery which you require needs a very high energy density. But if you take a case of e-rickshaw, electric rickshaw, then you have a lot of space available there. So energy density is not high there because presently they are working with lead acid, and if you replace with lithium, so you have a lot of space. So it depends on the application, what kind of application you are looking for. So coming back to the topic, we are in solar, and then now we are deeply in electric vehicles for last 4 years, because this market is the biggest market which is coming in India. Presently, you see all e-scooters and e-bikes, and then e-passenger auto, then e-loader. You see a lot of online orders these days and a lot of online work. So all these cargo autos are electric now, most of them. So this is a big market which is coming up. Even in four-wheeler, you know about the car. Car is picking up slightly slowly due to various reasons. But other applications, like if you talk of electric tractors, so you have pure electric tractor, then you have hybrid electric tractor. So all these are picking up very nicely. Then you have AGVs, automotive guided vehicle, and all this robotics, drones, and so many applications are there. We are even doing batteries for electric trucks. So we have developed a battery for a 60-ton truck, construction truck. So it is a 2-ton battery of 250 kilowatt hour. So that also we have developed. So this was a slight brief about what we all are doing and what our company is doing. Now we come to our topic of ESS. So I will just share my slide on that. Just let me know, share the screen. Just give me 1 minute.
Sure, sir.
So this is the presentation I have prepared for you. So you will see on the right hand side, on the lower side, there are small black racks. So this is the basic thing how we make a ESS. So ESS is made out of, I will show you how to make a ESS first, then we start with this in just 1 second. We start from here, then we come back to that slide. So you see there is a, on the left side, there is a cell. So I told you cell, we have two technologies. One is your NCM cell. NCM means nickel, manganese, and cobalt. Lithium is basically there, but it is known as NCM cell because along with lithium, nickel, manganese, and cobalt is there. And this cell voltage is 3.2. And one, we have lithium iron phosphate. So in place of these three elements, we have iron phosphate there, and the cell voltage there is 3.2. So what is the benefit there basically? Because now cell voltage is decreased, but we have a very high life cycle there. So we have 3000 charge and discharge cycle in lithium iron phosphate, whereas in NCM, the cycle life is around 5 to 800 only. So it depends basically what kind of thing you are using. Like suppose you are using a mobile phone or you are using a laptop, then you are using a NCM battery, because life of mobile and laptop generally we take it as 3 to 4 years, and usage is only 2 to 3 hours or 4 hours in a day. So consumption is not that much. But for industrial application, the selection is quite different. So coming back to this ESS, now the cell is one part I have explained you. Cells are, there are 2-3 types of cell, that also you should know, because once we are covering a topic, we should know the topic deeply. So it is a kind of a knowledge that one should have on the subject fully once we are discussing something. So cell generally, initially you all have seen the cylindrical cell. So cylindrical cells are there. which is for a small application, like you go to a store, there is a point of sale machine, POS, card swiping machine. So they all use cylindrical cell, small cylindrical cell. And then we have prismatic cell, what is shown here in the left side. These prismatic cells are of higher capacity. Generally, the cylindrical cells are of low capacity. They generally come in 2Ah or 2.6Ah or like that, and they come maximum up to 6Ah. So up till that, winding is easy and making a cylindrical cell is easy. But when you need more power, like suppose you need 100Ah or you need 200Ah, then you have to go for prismatic. So this is a rectangular cell. So this is prismatic, where you can have more capacity. And then we have one more type of cell, which is known as pouch cell. So in place of outer hard casing, you have a pouch soft casing. Inside material is same, basically the technology and the chemical is same. Only you have replaced the outside thing with a pouch. It all depends on the application, that what kind of application you are looking for. If you want to reduce the weight, what is the application? So it all depends on that. Then the second part is your BMS. BMS is your battery management system. Basically, this is the heart of any battery, because when you have cells, so cell is basically only 3.2 volt. Out of that, you will make a battery bank of a higher voltage. Like if you talk of ESS are generally designed in very high voltage of 600 to 700 volt, 2000 volt. So there are different voltages for the ESS. I think a lot of disturbance is coming in between.
Arif sir, I will just request you that if somebody
muted, sir.
Yeah, thank you very much.
Thank you so much.
That was a distraction basically.
So we are sorry for that.
No, not at all. It's fine. Life is like that. College life is like that. So one should enjoy. Not a problem. So then the second part is your BMS. So BMS is the battery management system. So when you club a lot of cells, because 3.2 volt is a very small volt, and you want to make a system of 700 volt, so you have to club few number of cells to make that kind of voltage. Now, every cell has a different peculiar behavior. So charging behavior is different, discharging behavior is different. So variance will be there because every cell has an internal resistance. So behavior of each cell is different. So you have a BMS, battery management system, will control the behavior of all the cells and keep them at same voltage, same level of the charge and discharge. So BMS is a very integrated part of any battery pack. Then BMS, we have a lot of features in BMS. BMS is basically meant for high cut and low cut of voltage and current, because these two are the important parameter in any ESS, your voltage level and your current level, that how much you want to draw a current and how much you want to charge. Similarly, the voltage. So BMS major function is high cut and low cut of voltage and current. Apart from that, it balances the cell. It has short circuit protection, balancing function is there. And then it has a function of sorry, it has a function of communication. So when these sites are placed at a very remote place, so communication is a big issue. Something working in an island or some forest or somewhere, you don't know, some heights on some mountain it is working. So communication is very important. So it has a RMS, remote monitoring system, and communication is done by a CAN2 protocol. CAN2 protocol is there. Basically, it is a closed area network. 2B type of protocol is there in that. So we communicate through a CAN2 protocol. So BMS has a CAN2 protocol, RMS, and it controls the input voltage, the output voltage, the input current, the output current. So it is a very important piece of component in the battery bank. Then what we do, because you need so many number of cells to make 1 megawatt pack or some bigger pack. So we can't make a single pack like that. So what we do, we design small modules. So what we will do, we will join 16 cells first of 3.2 volt to make it a 48 volt system, right? So suppose cell AH is 100. So what we will do, first we will make a cell module of 48 volt 100 AH, or maybe 48 volt 200 AH. So these modules are your 5 kilowatt module or 10 kilowatt module. So this is known as module. So now once there is a module of, depending on the size of the ESS, you make a module. So it could be 5 kilowatt or 10 kilowatt. Then you put these modules in series and parallel to make a defined voltage and defined backup. So when you put in series, the voltage will increase, and when you put in parallel, the backup will increase. So then we make this kind of rack in series parallel. So first thing is your module, then you put in tray, then you make a rack. So this rack is there, then this rack will go in the container. This rack will be clubbed here together to make the system. So now here we have defined 1 megawatt system with the energy of 1 megawatt hour. So see the configuration, how we have made it. There are 256 cells in series. So when you multiply 3.2 voltage of the cell with 256, then it will come to around 820 volt. That is nominal voltage. When you charge, it will go up till 1000. So nominal voltage will be around 800. And 18P is your 100 cell, 18 in parallel, right? So it is 1800 Ah basically. So 800 volt, 1800 Ah, you make it, and this will be the combination for this thing. And here we keep some margins also. When we design this system, see, no system will give 100% efficiency. So we keep parameters for temperature, because there will be different temperature range in different part of the country, or maybe international if you supply, like we export lot of things. So international, there could be minus temperature, there could be plus temperature. So we keep provision for all these parameters, like temperature. Then we keep provision for life. Suppose this life of this ESS is around 10 to 15 years, then definitely after 5 years it will degrade to some extent. After 10 years it will degrade slightly more. So we keep provision while designing all these factors about temperature and degradation and internal resistance, and then we design. So it is slightly over designed like this, right? Then you fit in a container, and now it is ready to go. When you fit in a container, then you put a HVAC also. HVAC is your heating and air conditioning system, basically heating, ventilation, and air conditioning. Because when you design something in IP65 or IP67 protection, then you need to take care of the temperature, the ventilation, the air conditioning, everything you have to take care, because when these batteries discharge, some heat is generated. So you sometimes you need air conditioning there. But if you are in a sub-Sahara region or in a negative zone, then you need heating also to start the battery, right? So all this system is inbuilt. So this container has battery modules, HVAC, and then we can have a inverter and transformer depending on how you want to transmit the power. So this is the basic construction of a ESS I have shown you. This is slightly more detail. We have a EMS also, which is known as energy management system, because like BMS is there to control the internals operation of the battery bank, but EMS is there to control the energy management. Because sometimes what will happen, like in evenings or late night, you need a lot of power suddenly, so surge is there. So energy management system will take care when the power is required more, or suppose in daytime you are charging from sun, and you are using some DC source also, and some extra power is there. So energy management system will see that how to fast charge the batteries and store the extra energy which was going waste basically. So this is there. Then you have power conversion unit. So all your AC, DC, everything whatever you want to convert, you can convert. So this is the cell module, and this is the system, and this is the battery rack, and this is the container. Then we have general application and what all uses of ESS. So you will see that there are different application of ESS. So how we can use. So on the first thing, you can see the different uses of a ESS, where the ESS will be used. It can be used as in frequency regulation, or it can be used as a community energy storage. It can be used as a residential energy storage. It can be used in peak shaving or in load leveling. So these all things are very important. Generally, what will happen? You have seen sometimes grid have collapsed. Even in Delhi, around few years back, 5, 7, 10 years back, the grid has collapsed totally because of frequency regulation. Because suddenly, if there is a high load and there is some something has happened on the backside of the supply, then a lot of distortion will take place. So what the ESS will do? ESS will notice any kind of distortion in frequency and give that amount of power to balance the frequency. So that is one function basically. Frequency regulation is important. Then we can have community energy storage. Like suppose you want to store some power in rural area. Suppose there is no grid, it is totally off grid, or in rural area where the power problem is more, you can store the energy, and whenever it is required, you can take out the energy. So that is one way of using it. Similarly, in residential, you have rooftop solar. So you in the daytime you have around good sunlight for around 4 to 5 hours. So whatever sunlight is available, you can convert and store in your batteries. And when there is a different rate of power, because some places rate of power is different in day and rate of power is different in night. So if the night rate is more, you can use the battery here to save that kind of peak charges. Then we have peak shifting. So this is again about the different usage of the power plants. Sometimes you have to change the peak shifting of it in renewable or in alternative energy. Then you can, the ESS can come in role where the power is needed suddenly. Then load leveling, what we have discussed in evenings, like load is more and in day the load is less. So you can store in the daytime more. So it levels. If there is a power cut, suddenly there is a storm or something, and the power cut is there, or some typhoon has come or something has happened, power is not there. So the ESS can take shape. So ESS uses are very different. And one more use is island used that I will show you in one of the next slides. So this is, you see how ESS has been put in different applications at different places. So while generation, if you use some extra power sometime, you can use a ESS there. While transforming, if there is some losses and if you want to use a ESS, you can use there. Similarly, you can generate from renewable, means it could be a hydro, it could be a wind, or it could be a solar. And this generation can be stored in ESS for use in the grid. So this is green energy you are putting up in ESS and then using in grid. And these are the applications where you use. It could be a house application, it could be industry, it could be a server, or it could be a microgrid, somewhere you can use. So there are many uses of this thing. So this is the inside view of a ESS. This one is the inside view where you see all these battery modules, what we were discussing, are placed in series and parallel, right? So this is the inside view. So you have different modules which are placed here, and then they are used for storing and use in this thing. Now, if you see some big system, then what we do, because we have a container of 20 feet or we have a container of 40 feet. This is all, you see the import export container, transporting containers. We design our ESS in those containers only because those are very sturdy and have a long life and very environment proof basically. So we design our ESS in those containers. So if you have a big system, then it is shown that how you series parallel the containers and use it in a substation or some other application. Now this is an island application, what I told you earlier, because see, taking grid line is not possible if you are sitting in Andaman and Nicobar or some remote place. So carrying a grid some 1,000 kilometers is not possible through sea. So at these places we have ESS. So in daytime we charge from sunlight, and in night we use this power. So this is known as island use. This is another application where you can replace a DG set with a ESS. You see a lot of people are using DG set when the power is not there, and it makes a lot of sound. Diesel filling is a big headache, and a lot of smoke coming out, another environmental issue. So you can replace this complete DG set with a BESS. So BESS will have an inverter and will have a battery inside it, and it can take care of the power outages. So even if you see in evenings in community parks, you have seen marriages are happening and 2-3 DGs are running outside. So you all can replace through a ESS. It is a better technology, environment friendly, and no noise, no pollution, nothing, no headache. So that kind of application also can be worked out. This is about the footprint basically. See, this lithium batteries are very compact. So you have seen lead acid batteries, they are very bulky, very heavy and like that. So lithium batteries are just 40% of the weight, and they take around 40% of the space, right? So it is a very small space you can accommodate a battery. It is a very lightweight battery and have a high energy potential, very low internal resistance. Maintenance cost is almost zero because the BMS is taking care of everything. and cycle life is around 4 to 5 times of lead acid battery, because lead acid batteries generally have a life cycle of 300 to 500 mostly. Some batteries have now come with 1,000 cycle also, but 80% of the market still is with the 300 to 500 cycles. Whereas in lithium, you have 3,000 cycles minimum. So you can see this lithium battery will last for 10 to 15 years. Generally, when we supply in the market, we give 5-year warranty on lithium battery because life is more than 10 years. So you have so many advantages. So this is the future prospects is shown here, that like smart cities are coming, smart grids are coming. So everywhere you have a solution which ESS can give you, and ESS can control all this green power when we store in ESS through renewable means or through other means. So we can decrease that kind of power through thermal, because all these coal-fired plants create a lot of pollution and a lot of emission and a lot of problems are coming. So ultimately, our focus is towards the green energy, and ESS is one part of the green energy. So these are the future uses basically. So I will show you one more slide. Just 1 second. For a better idea, I will show you one more. This is another slide I will show you. This will give you a slight fair idea how it is made basically. So you see these kind of technologies are there in the cell technology, what we are discussing about lithium. So you see here on the left side, we have a VRLA, the SMF VRLA battery, then nickel cadmium. This is lead acid, right? So you see the energy density both side. One is volumetric and one is with the specific. So watt hour per liter and watt hour per kg. So these two are there. So you can see this takes a lot of space, right? It is in the beginning of the chart. Then you have different technologies, nickel and other thing, and zinc alkaline, and then lithium ion. You see, it takes most minimum space, right? Because watt hour efficiency per liter is very high, and per kg is also very high, right? So we have selected this technology for ESS. There are different technologies. You can use different technologies. There is not a problem at all. So we have different modules from 12 volt to 800 volt. We have different modules from kilowatt hour level to megawatt hour level. So this all is written here. So this is the basic module, how it is made. I have just displayed for a better understanding. So now see, just 1 minute. We start from here. See, this is one module, right? This is a module of 48 volt 100 Ah. This is one module we have made. We have put 16 cells of 100 Ah, 15 cells of 100 Ah inside. 15 into 3.2 is 48 volt. So we have made put 15 cells in series and made a 48 volt module with a 100 Ah prismatic cell. So this module is ready now. Now we have put these modules in series parallel here, right? So now this is a single rack. So what we have done, we have made a here we have put few modules and make a battery rack in series. Okay. So now we have made a battery rack of 240 volt here. Then we have put these three 240 volt in parallel. So it becomes 240 volt 300 Ah. This is 100 Ah, this is 100 Ah, this is 100 Ah. So it is like that. 48, 48, 48, 48 into 5. So it becomes 240, right? 48 into 5 is become 240, and 100 is the individual capacity of the cell. So this is 240 volt module in 100 Ah. We have made 3 in parallel, so it becomes 240 volt 300 Ah. Okay. So this is the same drawing what I was showing you earlier. Now each module has a internal BMS. This is a BMS, this is a BMS. So it will control the parameters inside this module, everything it will control. But what will happen, because now we have 5 of them, so we need one more BMS to control the 5. Now these 5 have become an individual cell basically. So we have a master BMS here. So this master BMS will control all these small modules. So everything is in sync now, right? So now we do a parallel, and for these 3 parallel, we have one more BMS on the backside of the system to control these 3 racks. So this is known as 3-layer protection. So first layer of protection is here, second layer protection is here, and third is on the backside, right? So every time you increase this thing, you need accordingly the BMS. This is your display section. It is here. You see, this is the display. Now I'm showing in the big one. So this is the display. So it is showing your module level display. Each module and each cell, how it is behaving. So it is cell level display. It is showing the parameters of the cell, charging, discharging, variance, temperature, everything it is showing, right? This is module level display, how the module is working. Then you have different parameters. You can just operate these switches and you can see more things out of it. Similarly, we were talking of communication. So we have a communication port also available in this thing. So you can communicate also. Now this is megawatt level ESS. Suppose you want to increase more capacity, what we were talking of the containers. So each container is there and you can parallel them. This is further elaboration of same. This is a 20 megawatt capacity, like you have different containers and put them in parallel. So this megawatt level ESS used in grid balancing. So here, see, it is a very interesting slide. You see here the duration is shown in milliseconds, second, minute, and like that in hours. And here number of uses shown in month, day, hour, 30 minutes, like that. So in a different variation how you use. So you want to improve power quality, you use for some time, maybe 20-30 minutes, the power will stabilize. So use for some time. You want to regulate something, you use for some time. You want to have electric supply reserve, then you need reserve for complete month. So it is shown in a big way, right? So different uses are there of ESS, which are shown here. So and ESS are different kind of ESS are there. Today our topic is limited to lithium, but you have mechanical, like you have pump hydro or compressed air gas or flywheel storage. These are mechanical storage ESS. In electrochemical, we have lead acid storage, we have lithium storage, we have flow batteries like vanadium reflow, and or we have sodium batteries. So this is electrochemical. Then we have thermal storage, where you have molten salt or some chilled water storage or some thermochemical storage. Then we have electrical storage, which is mainly routed through supercapacitors or something like that. Then we have chemical storage. So these are the various ways of energy storage, but our topic is limited towards this red thing. We are talking only of lithium today. The topic is very vast and you can spend a lot of time on this topic. So this is all pump hydro, this is other application. So I think mostly we have covered the complete topic. Now this is last slide I want to show you. This shows that what kind of power you need and what kind of timings you need. So suppose you need something for a day, then you go for this section. If you need something for an hour or something for a minute, so it depends. These are the different technologies, like lead acid is there, fuel cell is there, sodium sulfur is there, compressed air is there, lithium ion is there, hydrogen is there, okay, natural gas is there, pump hydro is there, right? So if you need a big storage, you go for pump hydro, which we have shown in one of the slides. So different applications are there. So I think mostly we have covered most of the thing, and I am sure you are quite clear on the subject. And if you have any questions, then we take questions now.
Sure, sir. Thank you so much. Thanks a lot for the session. I will definitely invite the students, if they have any questions, they can come up with their questions.
Sir, meanwhile, since students are not able to unmute themselves, so if they want to ask, they have to raise their hand.
Mayank Prashar
they
is
can-
there. Mayank Prashar
Yes,
is there. He has raised his hand. If we can unmute him.
Now we can
Yes,
unmute
yes,
everybody.
we can.
There is no problem. Now the session is over. We will have a half an hour question answer session now.
So my question is that lithium-ion battery is complete a disadvantage which is temperature sensitive, or if the battery is completely discharged, that will damage the battery.
Mayank, you're not audible.
Voice is not clear, please.
You're
Slightly.
not audible, Mayank.
Mayank, you are not audible. Please put the question
Come
again.
up once again, Mayank.
Sir, yes, sir. So my question is that the lithium ion battery is temperature sensitive, and if the battery is fully discharged, then battery will damage, na?
No, it is not like that at all. These lithium batteries are not temperature sensitive, first thing, because these batteries work at the widest temperature range of -10 degree to +60 degree. So these are not temperature sensitive, first thing that we should be very clear. Because these batteries, you see, ambient in India generally goes maximum up till 48 degree centigrade. And when you discharge these batteries, then the discharge temperature is around 5 degree, right? So it can go up till 53 degree. But these batteries sustain up till 60 degree. There is no damage to the cell or the battery. Still, we have a BMS. The battery management system, we have temperature sensors at cell level, at module level, and these temperature sensors will sense if the temperature goes above 60 degrees, then it will trip the system to avoid any damage to the cell. So these cells and this technology and these batteries are best suited for different temperature conditions, because you have issues with lead acid batteries and other batteries in the temperature, but this battery behaves very nicely in any kind of temperature. Yeah.
Mayank, Mayank, are you there?
Yes, sir.
Okay. Fine. Thank you.
Thank you, sir, for answering.
Yeah, thank you.
Okay. Any other student who want to raise the question, please come forward. Arif sir?
Yes, sir.
Any other student is there?
Sir, I think there is no question from a student side.
Okay, okay. I think so. This was a detailed discussion. Sir has actually made a detailed discussion, and I think so. All the clarifications are sort of. Arif sir, we can go ahead.
Okay, sir. So, meanwhile, our director sir was also there in during the session, but he is not with us now. On behalf of organizing team, I welcome in his absence also. Now, I would like to request Professor Rahul Agrawal sir for the vote of thanks.
Thank you, Arifji. Thank you very much. First, I would like to thank, but it was a wonderful opportunity to have. And on behalf of Anand Engineering College, faculty, staff, and students, I wholeheartedly welcome you and thank you for delivering such a wonderful speech, sir, a program. It was a privilege to have you amongst us. It was your narration. It was like very enlightening, sir. And it is once in a blue moon that we get such a person with having such a deep knowledge base, sir. I thank you very much, sir, for giving us the insight about the energy storage scenario in India and the future with the perspective of lithium ion. I thank you very much, sir. I also would like to thank and extend my thanks to our Honorable Director, sir, Professor Shailendra Singh, sir, who has been staunch supporter of the fact that the only way to bridge the gap between the industry and the academia is through people like you, sir, Bhatnagar, sir. I give my wholehearted thanks to our director, sir, also. I thanks Dr. Senthil Subramaniam, who is heading our Industry Institute interface, who has been strengthening and reiterating, who has been strengthening our hands with our motto of bridging the gap between the industry and the academia, and he has been acting as an interface between the industry and the academy. Moreover, I would like to thank our head Electrical and Electronics Engineering Department, Professor Himanshu Vijay, sir, and Professor Aman Sachdeva, sir, who is heading the Mechanical Engineering Department, for helping us out with such a wonderful webinar. And my special thanks to all my audience who have been so much, I must say, a disciplined audience. It was wonderful to have all amongst us. I thank you, and thank you one and all. Thank you very much, sir.
Thank you, Professor Rahul Agrawal, sir. So it was really good to have you in our campus on a virtual mode. We will definitely love to bring you offline on an offline mode also, and we will definitely see to it that your presence in Anand Engineering College Technical Campus at Agra. Thank you so much, sir. Thanks for being on a virtual mode. Now we come to the close of this particular meeting. I will request all the dignitaries to leave the meeting. Thank you so much, sir. So you can leave the meeting right now.